at it. Okay, so that should be everybody then. Maybe we got everybody coming in who's going to get to come in. So we're going to look at just some mixed problems. This worksheet was called Mixed Problems Practice, I think, in the Google Classroom under, I think under the mixed problems day, which I think was like day 4. And so I thought this would be a good place for us to start because it'll allow us to go back and review the other types of problems. And I hope everybody's been able to access the videos and kind of watch the videos to understand how to work these problems. And I know that this is tough. This is definitely not the most ideal way to teach stoichiometry, but I will say, you know, I've had students who've had to do this in college who never even had chemistry, and they're moving at a lightning pace in a chemistry class in college, learning the same types of things. And so this is just getting you ready for your future. So I'm going to go ahead and we're going to look at this problem number 1. So what I want to do is I want us to walk through problem number 1 together and look at how you would work it. And then from there, we will look at how we would know what type of problem this would be. So my goal is for us to work just a couple problems together, and then I'm going to allow you to ask some questions because I know there's probably some that you've had a few questions about. So let me get my paper here. I'm going to fold this so that we can look at it. I miss my big podium at school where I have all that room to work. Okay, so this very first problem is they've given us a chemical reaction there. 4Na plus O2 yields 2NaO. And so the first thing that I'm going to notice is because this one already has coefficients, that's my clue that, hey, this one is already balanced for me. So that's one less thing that I have to do. So I'm going to write that down because I like to always write down my reaction so that I can work with it. So 4Na plus O2 yields 2Na2O. Okay, so on this very first problem, they ask us how many moles of sodium would be needed to react with 3.82 moles of O2 oxygen. Okay, so I can go in and look at my equation and I can put in my given and my unknown. So they're asking me how many moles of sodium. So I'm going to come over here above sodium and I'm just going to make that my unknown, question mark mole. All right, and then they tell us that we have 3.82 moles of O2. Okay, so this is my given, this is my unknown, and so now I can work the problem. So the first thing you do after you've written a balanced reaction is you write down your given and your unknown, and then you look at their units. So we're starting with moles. We need to find moles. So what kind, whoops, wait, sorry, hold on. So what kind of problem would this be if we're starting with moles and we need to find moles? Anybody want to take a guess?
Mole to mole.
Mole to mole. That's right, mole to mole. And mole to mole are the easiest ones because we don't ever have to deal with our periodic table. And so anytime we can, you know, not have to figure out molar mass, that's fantastic, okay? So what I'm going to do is I'm going to come down here and I'm going to start with my given. I've got too many chords and not enough space. Okay, so we have 3.82 moles of O2. And then we need to find moles of sodium. So to go from moles of one to moles of the other, I have to use my mole to mole ratio. So I have 1 mole of O2 because there's an understood 1 coefficient. So where do I need to put that 1 mole of O2?
The bottom.
The bottom. So I'm going to put 1 mole of O2 on the bottom. And then right here, I see that I have 4 moles of sodium, so that puts that on top. So now I can cancel out moles of O2, and that leaves me with moles of sodium, which is what I was looking for. So then I just plug and chug in my calculator. So I'm going to say 3.82 times 4 divided by 1, and I get 15.28 moles. So am I done? What do I need to do now?
Sig figs.
Sig
Sig
figs.
figs. I have 3 sig figs here, so my answer has to have 3. So 1, 2, 3, the 8 rounds it up, 15.3 moles of sodium. And that would be the answer for the very first one, okay, 1A. Okay, so does everyone see how I did that? I write down what my given was, write down my unknown, and then by looking at those units, that tells me what type of problem I'm going to work. And I'm going to tell you right now, when students work these problems in the class, I have found that the biggest problem with students doing stoichiometry is not necessarily the mechanics of stoichiometry, it's that they either go too far or they don't go far enough. Like they stop midway through the problem and think, oh, I found it, or they'll go and just keep on trucking rather than stopping. And it's because they didn't write down their givens and their unknowns, and so they do more work than they have to or not enough. So let's go on and look at 1B. So 1B, we're using the same exact reaction here. So I'm just going to go up here and scratch out these. Now, I typically don't use my answers as a given or unknown unless I absolutely have to, because if I got my problem wrong, then that means every problem after that would be wrong. So I try to use what they give me in the problem. So right here, they want to know how many moles of sodium oxide. So I'm going to come over here. This is going to be my new unknown. So how many moles can be produced from 13.5 moles of sodium? Okay, so take a second, look at your given and your unknown, and somebody tell me, what type of problem will this be?
Mole to mole.
Mole to mole, okay? So we're going to set it up the same way we set up this one, but obviously there's going to be different numbers. Y'all take just a second, and I want you to set up that problem, and let's see if you did the setup correctly. Okay, so this is how I set mine up. I started with my given, 13.5 moles. I put in my mole to mole ratio between the given and the unknown. So my given was 4 moles of sodium, so that goes on the bottom. The unknown was 2 moles of sodium oxide, so that goes on top. And so now I just plug and chug through my calculator. So I'm going to say 13.5 times 2, and I get 27. And then I'm going to divide that by 4, and I get 6.75 moles. All right, am I done?
No.
What do I need to do?
Sig figs.
A sig figs, I've got 1, 2, 3, 1, 2, 3, so that's good. I do need to put this here at the end. And that just makes it's a good habit to get into, so that way people know what that is that I found. All right, so does anyone have any questions on A or B right now? All right, well, let's go ahead and look at C. C, for that problem, we're using the same exact equation, But this time they want to know how many moles of O2 are needed to produce 34.7 grams of sodium oxide. So I'm going to go over here and I'm going to scratch out these. And then they tell me I have 34.7 grams of sodium oxide. And they want to know how many moles. Okay, so my given is in grams. My unknown is in moles. What's that going to be? Is it a
Grams to mole.
grams to moles? Anytime we see grams show up, I know I'm going to need my periodic table. Okay. If grams doesn't show up anywhere, then I don't need my periodic table because I have one of my figures in grams. I've got to have my periodic table. So let's go down here and let's work this one out together. All right. So we have 34.7 grams of Na2O. And I'm trying to get to moles of O2. But I can't do that because I can't do my mole to mole ratio because I'm left with grams. So how do I convert grams to moles? Crickets. How do I convert grams to moles?
Molar mass.
Molar mass. So down here, just off to the side, I've got 2 sodiums, 2 times 22.99. I have 1 oxygen. So when I put that in my calculator, 22.99 times 2 plus 16, I get 61.98 grams per mole. So now I need to put that in. So where am I going to put grams, top or bottom?
Bottom.
Top. Oh, wait. Grams going on top?
On the bottom.
Bottom. So 61.98 grams of Na2O on bottom and 1 mole of Na2O on top. Grams cancel out and I'm left with moles of sodium oxide. Was that what we were looking for? No. Now I have to bridge the gap. So to do that, I use my mole to mole ratio. So I had 2 moles of sodium oxide, that's going to go on bottom, and 1 mole of oxygen on top. And then those cancel out, and now I'm just going to plug and chug. 34.7 times 1 equals divided by 61.98 equals divided by 2 equal, and I get 0.279990 mole. Now this one's kind of a weird one when it comes to doing sig figs. I have 3 sig figs here, and right here I have 1, 2, 3. And that 9 rounds up that 9 to a 10, so that makes this 0.28. How do I make this 3 sig figs?
Add a 0 at the end.
Add a 0. And then that's my answer. Okay, so does everyone see so far how to work these? Does anyone have any questions so far? Okay, well, let's look on down that same worksheet and let's look at problem number 2C. Problem 2C. Okay, so for 2C, they give us this chemical equation, all right, and they want to know how many grams of O2 are needed to react with 2.56 grams of C2H4, okay? So let me come over here and get a fresh piece of paper. And I'm going to write out my reaction. C2H4 plus 3O2 yields 2CO2 plus 2H2O. Okay, and so they want to know how many grams of O2 are needed to react with 2.56 grams of C2H4. What type of problem is this?
Grams to grams.
Gram to gram. All right, so this is the big one. This is the longest problem of all of these types that we've done. And because we're starting with grams of one, I know I'm going to have to find molar mass of this. And because we're going to grams of this, I know I'm going to have to find molar mass of this. And just looking at some of the problems that have been turned in and a lot of the questions that I've been getting, this right here, this O2 is giving people fits. So we're going to work through this one together, and then we'll take a few minutes and just kind of debrief everything. So let's start with C. So my given is 2.56 grams of C2H4. And we're trying to get to grams of O2. And for me to get from here to there, I've got to have moles. So to convert this grams to moles, what do I need to find?
Molar mass.
Molar mass, all right? So I have 2 carbon, which is 2 times 12.01. And I have 4 hydrogen, which is 1.01. So when I run those through my calculator, I get 28.06 grams per mole. Okay, so I'm going to put that in, and my grams are going to go on bottom so that I can cancel out the grams. So those cancel out, and I'm left with moles of C2H4. So now I can bridge the gap from this to this. So I'm going to do my mole to mole ratio. So I have 1 mole of C2H4, and I have 3 moles of O2. So I'm left with moles of O2. But I can't stop because they want me to go to grams. So in order to go to grams, I've got to find my molar mass of O2. So it's 2 oxygens. So 16 times 2 is 32 grams of O2 and a mole of O2. And that cancels out. Okay? So now I just plug and chug. 2.56 times 1 times 3 times 32 divided by 28.06 divided by 1 divided by 1, and I get 8.76 grams of O2. And that's my answer. I see the Tiger King has joined our class. Okay, so that's a mole to mole, a mole to gram or gram to mole, and a gram to gram. Okay, does everyone understand how you decide what type of problem it is that you're working? Okay, well, that's kind of what I wanted to go over today, was just to make sure that everyone understood how to find the problem and to know what you're looking for. And I'm going to tell you, your key is writing down your known and your unknown. If you skip that step, it makes this very difficult because you don't know where you're starting from and where you need to stop. Okay? Does anyone have any questions so far about mole to mole, mole to mass, or mass to mass? Anybody? Okay. Well, we're going to stop here then. Next Tuesday we're doing another video where I'm going to go over, review over the stuff we just did. And we're also going to talk about limiting reactants. The limiting reactants activity has popped up, but the video is not there yet. So don't stress out about it. I'm hopefully going to get that put in today. And then we'll go over percent yield. So we'll definitely Zoom Tuesday, and we're probably going to Zoom we are going to Zoom Thursday as a review. I may throw another Zoom session in there Wednesday, just as kind of an extra help for those of you who might be struggling with limiting reactants, percent yield, or any of these types of problems, okay? Now that you know how to work mole to mole, gram to mole, gram to gram, you need to be in the Google Classroom getting days 1, 2, 3, and 4's assignments done. Because if you wait until last minute, it is a lot of work. And so, and it's not that it's hard, it's just that it's kind of tedious and there's a lot of little steps to it. But the more you practice, the better you get at it, and the easier it is to see when things don't really make sense, okay? Because the more you work, it becomes become second nature. All right, does anyone have any questions about anything chemistry related?
How many lessons do we have left?
We are going to do, right now, our next lesson is going to be atomic structure. And I'm working on it right now to see how long it's going to take us. And if I can get it done in a particular amount of time, we may go from atomic structure straight into the electron. That's the plan. And then I'm working on what we're going to do for our final exam. I actually talked to Mr. Hallmark about it yesterday because I'm not 100% sure how we're going to do that. But as soon as I know, I'll let you know. I've already got my other 2 classes kind of planned, so y'all are the next ones on the list.
Oh,
How are we
great.
going about ending the school year?
That's a good question. Mr. Well, let me stop the recording. Let's see. Mr. Fortenberry right now, he's